All right. Hello, guys. Um, so today you are just going to be finishing up the mole activity lab. Since we're not in class to ask questions, I'm going to just go over some of the parts. And if you have additional questions, remind, text, or message me. This will be due at the beginning of the period tomorrow, which would be Tuesday. We will not be working in class on it. So the top parts, the information parts, I went over it with some classes, other classes I didn't. So 1 mole of any substance contains blank particles of that substance. 1 mole, remember particles is a category. So this is the 1 mole is 6.02 times 10 to the 23rd of any of the particle labels, right? Which would be the atoms, formula units, molecules. The name for this is called Avogadro's number. Okay, that's the name for the number of that. All right, 1 mole of lead will be heavier or lighter than 1 mole of oxygen because, so if we look up lead on the periodic table, Pb here, you'll see that the mass is 207.2, whereas oxygen is 16. So remember, 1 mole is equal to the molar mass, or in the case of if it's just an element, it would be equal to the atomic mass there. So 1 mole of lead will be heavier because lead has a larger atomic mass than oxygen. Okay. Oh, sorry. Yes, we could zoom out a little bit there. There we go. Then the mass of 1 mole of a substance can be found using so 1 mole of a substance to mass, which the label we're using is grams, right? So it would be the molar mass of the substance. Okay. All right. So you should have numbers in here, the before, the after. You take the after, subtract the before, and you would have, now here, the change in mass, you could have a negative number because the change went down. So the molar mass of wax, okay, molar mass is the mass for 1 mole. This is what we've been doing for a long time now, which is you just take this, you take the number of atoms times the mass. Carbon is 12.0, so we get 300. And the hydrogen, there are 52 of them at 1 each, so that's 52. So we get the molar mass, 352 grams per mole for wax. Okay. Now, the next two are a little trickier. These, not because they're hard, just because you have to really read it, and it's doing something different than we've done for most of the other stuff. How many atoms of carbon are in 1 molecule of wax? Okay, this is not a grams to molecules or grams to atoms or moles to atoms thing. This is 1 molecule. So 1 molecule of wax is this deal right here, C25H52. How many atoms of carbon are in that? Well, you just look here. So it's 25 atoms of carbon are in 1 molecule of wax. How many atoms of hydrogen? Well, you look here, that's 52 atoms of hydrogen are in 1 molecule of wax. All right, next page. How many moles of wax were used during burning the candle? So it wants moles of wax that were used up. What do we have information-wise? Well, we have the before, the after, and the change in mass. Okay, this change in mass in grams is the amount of wax used. So you're going to start with the change in mass amount, okay, in grams, and you're going to convert from grams to moles. This is of wax, right? So grams on the bottom, moles on the top. It's 1 mole for the molar mass, which we already figured out over here. The molar mass is 352. So that's 352 grams per 1 mole. Okay, you just do the math and you get your answer in grams. This divided by that. Okay. Now, how many molecules of wax were used? Okay, well, to do that, you take this number from part D, whatever you get here. Oh, shoot. I'm sorry. I said something wrong a second ago. This is not grams on your label here. This should be moles because grams cancel. Moles. There we go. Okay. Sorry. You take your answer from part D, the number of moles, and you plug that in down here. So you're going to start with the moles from D. Okay. Then you convert moles to molecules. And this, remember, molecules is a particle label. So you're using 1 mole equals 6.02 times 10 to the 23rd. So 1 in front of the mole, 6.02 times 10 to the 23rd in front of the molecules. Okay. Then you do the math, take this times that, and you're going to end up with however many molecules is your answer. All right. Okay. Next part. The crayon and the chalk. So you should have mass before, mass after for each. Then the mass used. Now this could be positive because it's talking about the amount used. All right. So, and the same thing here, like for D, I guess I should have mentioned the change in mass you might have down as negative, and that's fine. You can leave it, you can make it positive here. Because it's the change in, so it's the difference between the two. Like you could leave it positive or negative. If you put negative, but because it says used, how much were used, like it would be a positive amount. You don't use a negative amount of something, okay? So down here, these numbers, if they're positive, if you do it, you can just make them positive because it's the amount used. All right. Molar mass of the crayon. Guess what? Look here. It's the same as it is wax. The crayon is wax. So you've already figured this out earlier. You don't have to redo the math. That's 352 grams per mole. Okay. How many grams of wax were used to write your name? Well, same thing. You're going to take the mass used here, and that's just this mass used, and that's just your answer for here. There's no math to do. Okay, you just write down however many grams. Now, part C, how many moles of wax were in your name? This you will. You're going to start with the grams from here. Start with the grams of wax that were used, and you're going to convert grams to moles. Okay, so here, remember, so this is the grams that you had in your name. The grams to moles, using the molar mass, it's 352 grams for 1 mole. You divide, you figure out the number of moles. I said this incorrectly last time. It's the number of moles that are in your name. How many molecules of wax? Same exact thing as before. Okay, you take the moles from up here, you start with that. So however many moles, and you convert moles to molecules. Again, using the same thing. 1 mole, 6.02 times 10 to the 23rd molecules. Right? You do the multiplication, you get the number of molecules that were in your name that you wrote. Okay. All right. Next page. Find the molar mass of the chalk. All right. This one I'm not going to do for you. You can do it. You're going to do the same thing that we did here. You take the element. So you're going to have calcium. You're going to break it up: calcium, sulfur, and oxygen. You take the number of atoms of each times the masses. You add it all up. Okay. Then you're going to take, for part F, how many grams of chalk. So you are going to take the grams of chalk from here, okay, from your table, and you're just going to write it directly here. No math. You just transfer it from this table. Okay. Then, how many moles of chalk? This is going to be the same thing you were doing for the wax. You're going to take your grams from here, and you're going to convert grams to moles. Okay, grams to moles, the molar mass. You're going to use the molar mass for the grams that you found in part E for the gram, 1 for the mole. And you're going to find the moles of chalk. How many formula units of chalk? Well, same thing. Formula units is just another particle label. So you're going to take moles from there, and you're going to convert moles to formula units. Right? This is the same conversion we use for the molecules. It's 1 mole. This is a particle label, so it's Avogadro's number. And you're going to get however many formula units. Okay. All right. So, last part. You should have the masses for each of these, for each of your things here. Okay. Oh shoot, I forgot to do this. Let's see. Let me pause this real quick. All right. Sorry about that. So I forgot that I forgot that I had told some people, and there was a couple of classes that didn't really have enough time to finish everything. So I had mentioned that I would give numbers for the chart. So if you were not able to finish the measurements for all of these, you can use the numbers I have here. Okay. To use those for the masses. If you have your own numbers, use your own numbers. Okay. So for these, it says measure the mass of the items on the scale and fill in the chart below. You do not have to show work for the numbers going into this chart like you do for some of the others. So you've got these, you need to find the molar mass. Remember, finding the molar mass is just doing the number of atoms times the mass and then adding them all up. Okay, I have aspirin down here because we need to use it in the next question. So this is aspirin. Aspirin is 180. And I want you guys to figure out the other ones. So aspirin is 180 grams per mole. Okay, now all you do to find the number of moles is you're just taking the mass. Grams is the same conversion we've been doing, right? And it's grams per mole. Okay, so if I do the number I have here, I get now 3 significant figures, so mine's going to be 0.00414 moles. Okay, so if you look at what we have here, basically what we're doing is we're taking the mass divided by the molar mass, right? So you don't have to show this work. You can just take this number divided by this number, and that will get you this. Just remember how many significant figures. You should have at least 3. Because your mass should be at least 3. Like this one, I would have 4 because I got 4 significant figures here. Okay, so make sure you take it out to enough significant figures. So you're going to do this divided by that for each of these, find the molar mass. Okay. Now, the last one, part A. Here, find the percent composition for each element in the aspirin, which is C9H8O4. So you have to find the molar mass. Okay, we need this written out because we need certain parts of these. Right, so you've got to find the molar mass, which we know is at 180. You need these numbers here. You need the total for each element, the 108, the 8, and the 64. Then to find the percent for each one, all you do is you take, so like for carbon, to find the percent of carbon, you take the mass of carbon divided by the total. So 108 divided by 180 times 100 to get a percent. Right? Do the math, and we get 60%. Now, these don't have significant figures, so I want you to take all of your numbers that are percentages to 1 decimal place for the type of percent composition when it's just the formula. Okay, now you're going to do the same thing with each of these. You're going to take the hydrogen over the total times 100, get that. You're going to take the oxygen, total oxygen over the total for the whole thing times 100, and that'll give you the percent composition for each. Okay. If you guys have more questions, let me know.